There is a mineral buried deep in the Earth's crust for millions of years that NASA began studying back in 1946 for use in aircraft engines. The military applies it to the inside of gun barrels to reduce friction between the bullet and the barrel. It powers satellites orbiting above your head right now, and you can buy it today at any auto parts store for somewhere between $2 and $8. It is called molybdenum disulfide, or MOS2, and there are people who have been adding it to their engines for years, with results that, according to them, are hard to explain any other way. One user on a mechanics forum has accumulated over 500,000 kilometers across several vehicles, each surpassing 240,000 kilometers without ever needing an engine rebuild. Another says his lawnmower stopped burning oil for years, after adding just a few drops. A third claims that the vibration in his steering wheel at highway speeds vanished completely after the very first application. Exaggeration? Placebo effect? Or is there something real here that the big lubricant brands would rather you not think too hard about? To understand, you need to see what happens inside your engine every time you drive. Inside the block, thousands of parts move at incredible speeds, pressing against each other under brutal pressure. The crankshaft, pistons, camshafts, bearings, piston rings, what looks perfectly smooth to the naked eye is, under a microscope, a jagged mountain range. Peaks, valleys, microscopic irregularities everywhere. When two surfaces rub together, those peaks catch, wear down, and tear away from each other. That is friction. Motor oil forms a protective film between these surfaces, but there are moments when that film fails completely. The cold start is the worst. After hours of rest, the oil has drained back into the sump. In the first few seconds of operation, before the oil pump pushes lubricant everywhere, the parts are essentially running dry. Engineers know that a disproportionate share of the total wear a motor accumulates over its lifetime happens in these first seconds, not over 100,000 miles of highway driving. And it is exactly here that molybdenum disulfide enters the picture. MOS2 has a molecular structure unlike anything else. Imagine a stack of playing cards lying flat on a table. Each card is held together with strong bonds, but the connection between one card and the next is extremely weak. Apply pressure or movement to that stack, and the cards slide past each other with almost no resistance. That is precisely what happens with the layers of MOS2. Its coefficient of friction sits around 0.025, one of the lowest values ever measured for a solid material. Steel on steel without lubrication is around 0.8. Conventional motor oil brings that down to somewhere around 0.1 to 0.15. MOS2 takes it to 0.025. This is not a marginal improvement. It is a category change. When added to your oil, MOS2 circulates in microscopic particles between 1 and 100 micrometers in diameter. When these particles reach a zone of metal-to-metal contact under heat and pressure, they physically bond to the metal surface. They embed into the microscopic valleys and crevices of every machined component. They form a solid film that does not drain away, does not evaporate, and does not fall back into the sump when the engine is off. When you start the car after a cold night, that layer is already there. The parts are not running dry during those critical first seconds. The history of this compound is fascinating, yet most people have never heard of it. Molybdenum as an element was not discovered until the 18th century, but the mineral molybdenite, essentially MOS2 in its natural form, has been used for centuries without anyone fully understanding why. Japanese swords from the 14th century contain traces of molybdenum in the steel. Smiths of the era used it intuitively because it made the metal harder, even though they had no explanation. By the 20th century, during World War I, the demand for molybdenum as a steel alloying element drove the opening of mines in Colorado that remained operational into the 1990s. In the 1930s and 40s, engineers systematically studied its lubricating properties and discovered something remarkable. MOS2 maintained its lubrication under extreme conditions where every other lubricant failed enormous pressures, near total vacuum, temperatures up to 350 degrees Celsius in oxidizing environments. In 1946, the organization that would later become NASA formally initiated a research program into MOS2 for aerospace applications. Today, it is present in the mechanisms of satellites operating in space, military helicopter rotors, sniper rifle barrels, high-end bicycle brakes, and in the CV joints of virtually every modern vehicle. If MOS2 is so effective, why don't manufacturers just include it in factory oil? The answer has several layers. Some oil manufacturers do include molybdenum, but in the form of oil-soluble organic compounds rather than solid MOS2 particles. Brands like Redline have a strong reputation among enthusiast mechanics precisely for their high molybdenum content in this soluble form. Solid MOS2, however, presents technical challenges in modern engines. It can interact with certain additives already present in the oil, specifically calcium and zinc compounds, and under some conditions, particles can agglomerate into larger clusters that might affect the oil filter. There are documented cases, though not widespread, of users reporting problems after using MOS2 in very modern engines with extremely tight tolerances. Critics also point to the financial interests at play. Car manufacturers make money selling replacement parts. An engine that runs 400,000 kilometers without needing anything generates far less parts business than one that starts showing problems at 150,000. That does not mean a conspiracy exists, but it creates an environment where actively reducing engine wear is not the top priority for every stakeholder in the industry. Let's be clear, MOS2 is not magic. It does not resurrect dead engines. If your motor has a rod knock, severe ring wear, or a blown head gasket, adding this additive will accomplish nothing. Many forum users leave negative reviews for precisely this reason. They bought it, hoping it would fix an already destroyed engine, and of course, it did not. What MOS2 does do, consistently, is reduce friction in engines that are in reasonable condition, especially high-mileage engines where normal wear has gradually opened tolerances between components. Laboratory studies show reductions in the friction coefficient of up to 26% when used at the correct concentration. Users on specialized forums consistently report improvements in fuel consumption between 1 and 3 miles per gallon in high-mileage engines, reductions in mechanical noise, and, in some cases, elimination of annoying oil consumption that had been progressively worsening. One particularly interesting case involves a user whose engine had a growing valve train tick. After adding the additive, the noise disappeared within 10 minutes. Another reports that his 1,999 Toyota Camry, with 200,000 miles on the odometer, sounded like a young engine again after the first application. A third claims a stuck valve lifter freed itself with the product. These testimonials are subjective, but their consistency across years and different platforms suggests that something real is happening, even if it is difficult to quantify precisely. The debate becomes more complex with modern engines. Conservative mechanics and some vehicle manufacturers argue that a good synthetic oil meeting the manufacturer's specifications is sufficient, and adding anything else could disrupt the precise balance of additives the engineers calculated for that engine. Volkswagen, for example, explicitly recommends against using any oil additives. Modern oils are extraordinarily sophisticated, with every component existing at a precisely calculated concentration. Adding an external additive can alter that balance. Solid MOS2 particles in particular can interact with the oil's detergent package in unpredictable ways. However, experts note that the risk of negative interaction is much lower in older engines, running conventional or basic semi-synthetic oils. It is more real in the latest generation of engines with very strict oil specifications. If your car has more than 150,000 kilometers, a relatively conventional engine design, and you are not running an ultra-premium latest specification oil, MOS2 is probably where it can help the most, and where the risk is genuinely lowest. There is one more practical thing worth mentioning. The effect of MOS2 is not permanent. The particles gradually wash away, and the oil degrades the deposited layer over time. To maintain the benefit, you need to renew the treatment with each oil change. The good news is that once you have done the first full treatment, many users report that half a dose at subsequent changes is enough to maintain the effect. At $8 a can, that means $4 per oil change to potentially extend your engine life by tens of thousands of kilometers. Not all MOS2 formulations on the market are equal. Some products use MOS2 as the primary active ingredient, like the Liqui Moly anti-friction treatment, which is probably the most documented and widely tested. There are also pure powder versions you can mix directly into the oil yourself, with 99% purity and particle sizes of 1 to 2 micrometers, the optimal dimensions for passing through the oil filter without clogging it, and reaching every contact point in the engine. Dosage matters. More is not better. Exceeding the recommended amount can produce the opposite effect, with particles aggregating into each other and forming unwanted deposits. The manufacturer's instructions are not just cautionary marketing, they are real chemistry. We live in an era where information about mechanical engineering is more accessible than ever. Anyone can read studies published in tribology journals. Forums with tens of thousands of amateur and professional mechanics have been documenting their lubricant experiences for decades. In that ecosystem, MOS2 keeps generating debate precisely because its results are real but variable. It does not work the same in every engine. It does not work if the engine is already severely damaged. It is not a magic solution that replaces proper maintenance. But in the right context, in a high-mileage engine in decent condition, it appears genuinely capable of extending engine life, modestly reducing fuel consumption, and making cold starts significantly less damaging over time. The science behind this is not speculative. The friction coefficient of molybdenum disulfide is among the lowest of any known material. Its ability to bond to metal surfaces under pressure and heat is documented in hundreds of peer-reviewed studies spanning decades of research in tribology, materials, science, and mechanical engineering. Its use in mission-critical applications like aircraft engines, space satellites, and military equipment is a verified engineering fact, not a marketing campaign invented to sell bottles at the auto parts store. What remains uncertain is how much of that physics translates into measurable benefits in your specific engine, under your driving conditions, at your specific mileage. But here is what we can say with reasonable confidence. If you have a car with high mileage, an engine in reasonable shape, already showing signs of wear, if cold starts come with that small initial tap that disappears once the engine warms up, if there is annoying oil consumption or a level of mechanical noise that was not there a few years ago, then spending between $2 and $8 to add molybdenum disulfide at your next oil change is one of the lowest risk, highest potential return bets you can make. In the worst case, absolutely nothing happens and you are out a few dollars. In the best case, your engine lasts 100,000 kilometers longer than it would have without it. Your fuel economy improves measurably, and those cold start noises that made winter mornings stressful simply stop. Along the way, you know you are using the same technology NASA employed to solve lubrication problems in the vacuum of space, the same technology military engineers rely on for precision weaponry, and the same trusted compounds satellite manufacturers count on to keep mechanisms running for decades, with zero maintenance, 500 kilometers above the Earth's surface. Not bad for something that fits in the palm of your hand and costs less than $8.